In this video, I'm going to walk you through the process of using the MaxIm DL6 software to create a colorized image from monochromatic images taken from a telescope using various filters. And so the MaxIm DL6 program, the icon looks like this blue swirly icon. Before we get into that, I'll take a look at the data that I have itself here. These are images taken for an object named NGC 1579 in the file name there. And there are three filters present. B stands for blue, R stands for red, and V, which stands for visual and corresponds to the yellow-green region of the spectrum. So those are individual filters placed across the camera to collect light only from those portions of the spectrum. There's a fourth file version here called clear, which is unfiltered, and literally that means that there's nothing in between the sky and the camera itself. So no filter, no glass or anything. All right, so I have three different sets of sequences of images here. 1, 2, 3, as you can see in the file names R 1, 2, 3. And I'm going to open them up first in MaxIm DL. So actually, before I even do that, what I want to do is create a backup. So I'm going to create a new folder, call it Original Data, and then I'm going to copy all of my files and put them in there. Because if I mess anything up along the way, what I don't want to do is be out of luck. So I'm not going to touch that folder now. That is my raw data, so to speak, and I don't want to mess with it unless I have to come back and start over at any particular point. So let's open up MaxIm DL. Now I can open up those images in a couple different ways. My first step after I've created that backup folder is to actually assess the data itself and make sure that I don't have any images that I really don't want to use. I want to make sure that the data that I'm going to use is good. So I can either go to File, Open, and select the files that way, or if I have a relatively reasonable number of images, I can actually just highlight them all and drag them into MaxIm directly. And it'll take a moment to open everything. And at the end, this is what I see. Expand that so I can see it a little bit better. So there are a number of different images. They're overlaid. You can see the nebulosity and some stars in the star field and so forth. Now I want to go through and look at each one of them individually. And if I only had a few, that would be pretty easy. But with this many, it's not quite as easy to do that. So I'm going to go up to the View menu, down to Animate, and you can see a list of all the images that it says available, all the images that I have opened up in MaxIm. So I'm going to add all of them. I could select from them and add them to the list here, or I can click Add All. If I click on any individual one and hit that button, then it removes it from the list that I'm going to play through. I can align them. So what aligning does is it looks for a number of different stars in the frame. So align mode here, I can use star matching. It will look and say, okay, I found 12 images. The first one is the reference. So that's the one that's the reference image there. If I click OK, it's going to go through and do a little bit of alignment on those images so that now I can click OK. And when I play through them, nothing should bounce around. All that I should see is the individual frames changing from one to the next. So I'll expand that a bit so that I can... That didn't quite work. Let's use the little magnifying glass here. There we are. And that might have been too much, so we'll back off. Okay. Yeah, you can see that that's... There we go. A little bit off the screen. I'll adjust it a bit. I want to really be able to see the entire image if I can. It's not always convenient based on the window sizes and stuff, but we're doing the best we can here. Alright, that's pretty much it. Okay. And now, so in this little animation window here, I can set the amount of time between each image. 0.2 seconds is a little bit fast. I want to be able to actually observe each frame on its own. I could just step through each one using this button here. Or I can actually play and watch the whole thing. So what I'm looking for are a couple different things. I'm looking at the star images themselves to make sure that they're circles and not lines or streaks or ovals. I'm also making sure that they are solid and not donuts, which would indicate that there's a focus problem. What I'm noticing already is that in some of these frames, or like this one here, the nebulosity is softer, the star images are bigger, and so this is the clear image. It looks like it's a little bit out of focus. So I might not want to use those ones unless I absolutely have to. The advantage of the clear filter is that it provides a bit more information about the subtle brightness differences at the faint level. I'm going to see if I can get away with not using it because I'm not too happy with how out of focus that image looks compared to some of these other ones. So this is an R filter image here. You can see the star images, each of the little dots got smaller, and so that tells me that those things are pretty well focused. Whereas when I jump to the clear, I'm not quite happy with that. So we'll see. Sometimes it doesn't matter, in particular if I'm aiming at color, but I'll play with it a little bit. Anyway, so I'm noticing that at the very least, there's no tracking issues. That would show me that the stars or that would reveal itself by stars being streaks. There's no serious focus issues because the stars aren't donuts. I also am noticing that there's no general gradient in the background, so there's no there are no frames where one side is a little more illuminated than the other. If that was the case, I could actually fix that. That non-uniform background can actually be fixed in the filter menu. So in filter, there are actually a couple different tools to try: flatten background, auto flatten background, auto remove gradient. And what that will do is it will look at the image and try to fit a function that describes the gradual change in the non-uniformity and then subtract it off. It doesn't always work well, but it is worth a try if you notice that one side of the image is bright and the other side of the image is faint. That can be a pretty handy correction factor there. But for me, when I'm looking at this, the other thing that I'm looking for is just to kind of get into my head whether there are any stars that have bloomed. Blooming is a feature that that shows up when there's an overexposure. So when any of the stars have saturated their pixels, and so the electrons have spilled over into adjacent pixels, and that shows up as a big streak coming out, usually in the brightest stars. It's not the little X shape that you can kind of pick out here, this X feature around that fairly bright star. That's actually diffraction of light being scattered and bent around the X-shaped support structure that holds the secondary mirror on the telescope. So that's okay, we're not trying to fix that. But sometimes the brightest stars, you might notice there's a big streak, sort of an ovalish streak that extends out, usually down in our case, coming out of those star images. If that was true, I could also fix that, and we'll walk through that process a little bit later. Although actually this would be a good time to do that now that I think about it. So fixing the blooming can be done, as it's called, by going up to the process menu here and remove bloom. And so I can just kind of illustrate what that looks like. You can set the saturation level. So the saturation level is basically the number of counts or in each pixel. So as I move my mouse around, you can see down along the bottom there, at the very bottom, there's an I. It says I 1516.512. As I move my mouse around, that number more or less stays the same because that's the background. But when I put it on the star, I get up to 55,363.371 counts within that star. So I can set this. It turns out that the saturation level for stars is typically around 60,000. So I can set that there. And if I hit automatic, no blooms detected in this image, so that's good. If there was a star that had saturated, it would find it and put a little box around it. If you see a star that has bloomed but it didn't find it automatically, you can actually use manual and clicking kind of what your goal would be to do is to try to draw a little box that just holds the star and the blooming feature in. So usually it looks something like that. Once it understands what you're up to, it will put a little red box around there, and you can preview before accepting it. Now you notice since there's no blooming, it isn't actually able to do anything, so there's really no difference there. If you like what it's done, you can click OK. If you don't, you can click Cancel. Obviously there's no blooming here, so I'm just going to cancel that. This is actually a great time to do that fixing if you see it in any of those images, because it's easier to do in the grayscale, the monochromatic versions, than in the colorized version. So I'm going to do a quick scan through here once again and just look for that blooming. I'll zoom in here one click, and I'll set it to, say, half a second now and just play through. So I'm going to keep an eye on that bright star that I was just looking at. Since it's fairly close to my target, I would want to know if I need to do any correction beforehand. So I know that I've got just 3 sequences. As I cycle through these sequences, I notice that that star never saturates. There's never any blooming. There's a little bit of non-uniform illumination off to the side here, but I'm not worried about that. I'm probably going to wind up cropping that out of my final image anyway. So all looks good. My frames are all in good shape and something that I plan on using, and so I'm ready to move forward from here. The next step then is to combine these frames into master frames. So I have 3 taken from each filter. If there were some that I had noticed were not usable, then I would want to move those out of this folder somewhere else. So I might create a folder called unused or something and put them in there. But since I do plan on using all of them, then I'm going to keep them. So in this case, the easiest way to go is to first close all of them. So I'm going to go to File and Close All. It's going to ask me if I want to save the changes. You'll remember that I used the alignment tool when I was doing animation. I'm not going to retain that alignment just yet. We'll realign later. So I'm going to say no to all, just to close them all back up. Now I'm going to combine filter by filter. So I have 3 of each filter here. I don't want to combine B with R. I want to combine B with B with B. And so I'm going to take, I'm going to take all 3 of those B frames first and drag those into MaxIm. So I'm just going to combine these 3 B frames first. And so at this point, I'm going to go to, now that I have all 3 of my images open, I'm going to go to Process and Stack. Stack will allow me to align them as we go. So Add Images, and I can select these. So Add Images shows me the images that are opened up here. I can click Add All, and then OK. If I didn't have those images loaded, I could instead go to Add Files, and it would then open up a different window that would allow me to navigate and locate those files directly. So they're right here. I'm going to move through the various settings, leave quality alone. Alignment I do want to do, so we'll go to, again, Auto Star Matching. Color, we'll leave the color alone since they're monochromatic. And Combine method. So in this case, I have a few different options. Averaging is okay if you have a lot of frames, and by a lot I mean maybe more than 20. But the problem with averaging is if you look at this image here, you see a little bit of speckling happening where there are some hot pixels or something that, or just maybe electronic noise that hasn't quite been removed. When it tries to add these, it will take a look at each pixel position and add the 3 values together. And if I'm doing an average, it'll just divide by 3 then, because I have 3 frames. An average is negatively affected if one of those 3 values is very big compared to the other 2. So you can imagine averaging 1,000,000 with 100 and 100. So you're going to get a value that's very large, much larger than 100. So we don't want to do that. So taking a median for small numbers of images is actually better. A sigma clip works fairly well too, again, if you kind of have an intermediate number where it'll look at the distribution of values for each pixel and then clip off or disregard values that are beyond some number of standard deviations or something. but given that we only have 3 there, that's not going to be well constrained either, so or well calculated. So we'll use median, and I want to set this to 16-bit integer. Under normalization mode, I'm going to click None, and then we will click Go. Okay, so you'll notice a 4th window is open down here now, so I'll close this. And this is my combined frame here. So I'm going to zoom in on that a little bit more, just to take a peek. I still have these bright pixels here. I think the camera is a little bit noisier in blue, so I know that that's probably what's going on there. If I had a lot more frames, or if the telescope had shifted significantly between each frame, then I could have gotten rid of that. But as it is, there's not much I can do. So this is my master frame, so I'm going to save that. I'm just going to call it master B, since it was the master B, it was a B filter. And I want to make sure that I put it in the right spot so that I don't lose it. Alright, master B right there. Uncompressed, manual stretch, 16-bit int. That's fine. I'm going to leave that alone. Great. Close all. And then I repeat the process for the other filters. I won't show you all of those. Whoops. But I do want to show you one more because it there's an important step that you need to notice. So I'll drag my R images in here. Now once again I can go to Process and Stack. And what you'll see is on the left side there's this group of files that are here right now. I don't want that group, so if you leave that there, because the images are closed, it will try to, what it's doing is it's remembering your previous stack with the B frame images, and you don't want that since you're not combining the B's, you're combining the R's now. So you need to right click and get rid of that, remove item. Now you can do an add images, grab the R images and put it on there. It will crash on you if you don't do that. So that's probably the most important step, or one of the most important steps as you're doing this. Again, auto star matching, combine, it remembers all of our previous settings. So we'll click Go, and there it is. That's my master R. So I'll save that. Master R, save, and done. So we'll do that a couple more times with the other images. So go through that same process for all the other filters that you have where there are multiple images in your set. If you only have one frame from any of the filters, then obviously that is your master and you wouldn't need to stack that. So I'll finish this up and then show you what's going on next. Okay, at this point now I have all 4 of my master images made and opened in MaxIm. And so now my task is to actually do the color combining. So there are a couple tools that are worth looking at this point. I want to be able to see the fine detail in my image. So in the View menu, let's go down to Screen Stretch. There's a little menu now. It's focused on the image that's highlighted here, so you can tell by the bar above it that it's the one that's selected. And what you're seeing here is a histogram of the data values, the pixel values. So there are a lot of values that are low because most of the pixels are black or close to it, and there are relatively few pixels that are bright, since most of the stars are black and most of the sky is black. Now, the one thing that I want to do to be able to see the detail is to take that red triangle there, which indicates which pixels are assigned a black color, and drag it to the left. As you can see there, then if I drag it all the way, then no pixels are assigned a black color because I've dragged it all the way to the bottom. It's hard to see what's going on there, so I can actually zoom in. I'm going to drag this green triangle up first. This green triangle indicates which pixel values get assigned a white color. So if I drag that up, it makes the image darker because fewer and fewer pixels are being assigned a bright color. So if I kind of bookend the distribution here a bit and then click the magnifying glass, I can see what's going on better, and I can bring that red, the 0 point, back up, so I don't have that background gray color in my image. And then I can even bring the green one back down to brighten up any details, and you can play with that a little bit just to see how good you can get it. What you're really looking at is the overall structure here of the frame. So we can do that for each one. Alright, now that I've done that a bit, I'm going to go up to Color and Combine Color. In this window, I get a chance to indicate whether I'm just using RGB, red, green, blue, or V instead of G here, or L, luminance or clear. So I'm going to try that with the clear, so that makes this drop-down menu activated. Conversion color I'm going to leave set to this one. And if I didn't have a clear image, then I would just use RGB. So there are some cases like star clusters, for example, where you wouldn't necessarily have a clear or luminance image. So that one deactivates that. But since a nebula usually benefits from some sort of luminance or clear image, then I'll select that. I'm going to need to align them. We're going to allow resize and auto equalizing on the backgrounds, because each filter has produced a slightly different background there, and we don't want the resulting image to have an overall green or red color or something. Also, because each filter is made of a slightly different kind of glass, the focal length, or the focus, is a little bit different, which means that the image scale can be a little bit different. So that is, the distances between the stars can actually change slightly. So we're going to allow it to resize when it combines them together if it needs to. In this menu, we'll just go through and select our images. Sometimes it already figures it out, but when there are letters it's not familiar with, then it doesn't. So I'm going to set luminance weight also to 50, just to start. Okay. Now at this point, it's giving me a little bit of a preview, but the preview can be screwed up depending on whether the alignment worked or is good or not. So let's just go ahead and do that right now. We'll set the alignment and to auto star matching. Okay, you see it's a little bit different now. This little preview window here is a little bit tricky to use. I'll set that back to 50 again here. And so what you'll find is, so these little plus or minus can allow you to zoom in there. Turning auto on and off gives you the ability to see what's going on there. A full screen preview is my preferred way to go, just because it does allow you to see the full image a bit better. The downside to that is whenever you make changes in here, you gotta reopen that again. So I'm going to also adjust the screen stretch on this frame. So that I can see what's going on here a little bit better. Alright, so there's the nebula. Now it's Not great in terms of what I'm expecting for the color, but that's okay. I have the opportunity to actually change the colors here. In case you have no sense of what to expect out of the colors, you can always Google your target. But be careful when you do that, because a lot of the images that you'll see will be taken from the Hubble Space Telescope or someone's larger telescope, maybe a professional instrument, or someone who used a lot of exposure time compared to yours. And so in that case, things like the really faint features will be really crisp, and you'll see a lot of stars if they've exposed it for a long time. If it's a large instrument, you'll see similar effects where you have a lot of detail that shows up. But so overall, so you kind of take a holistic view of these pictures and go, okay, I see. For the most part, it looks like it's actually pretty reddish orange. This is a diffuse nebula. It's called an emission nebula. The emission comes from excited ionized hydrogen atoms, and so I should actually expect my image to look kind of like that. So coming back here, it actually looks a little bit too orange to me, and so orange means that there's a lot of red represented and not a lot of blue. And so that's what these numbers are for, input and output. These are multiplicative factors that take each of those master channels here and they multiply it by a certain amount in order to amplify that particular color value in your final product. Now you got to be careful a little bit because it also amplifies noise. And so if you go too high, then that can become a problem. You'll notice some speckling in the background if that's happening. So usually keeping the red for my camera, or for our camera, I know that the red is the most sensitive portion of the chip, and so I'll leave that at 1. And then green and blue, those numbers I'm going to turn up. Usually you keep them between 1 and 10. So I'm going to start with the blue, and I'll just multiply it by, say, 1.5 instead. Again, my preview went away, and so I see that. So now I'm going to try, and sometimes it's good to just experiment here. If you really wanted to see what's going to happen if you crank it up a lot, then of course I turned up the blue to 10 times. So now I'm getting this sort of purplish color, and if I zoom in on that, you'll notice that those blue, the blue electronic noise that's in the blue master frame is starting to show up, which is not good. So that was too much. So if I turn it back down to, say, 5, things are starting to look a little bit better. Now what you're going for on this is the idea that you're not just trying to match the color of the target. Sometimes you won't know what that color is supposed to be. But generally speaking, a lot of the stars in the frame are going to be in the neighborhood of white. You'll notice that there should be some blue and some red stars, especially if you have long exposures in those frames. But overall, the majority of stars will be in the whitish range, especially those bright ones in the center region there. If you're doing a galaxy, the very center of the galaxy will also be a white color. One thing to think about too is this luminance weight. So the luminance weight is the amount of contribution to this frame that your luminance or clear image is contributing. If I set that to 0, the color will come out better in my preview, but I've lost some detail on the background. And so if you set this up too high, then you won't actually get a lot of color information because the clear or the brightness is overwhelming the color. If you set it too low, then you get a lot of color information, but not a lot of information about the faint structure, which is especially important for galaxies and nebulae too, depending on what kind of nebula it is. So you're trying to strike some sort of balance here for between the color and the luminance weight. And really, this is kind of the secret of colorized astronomical images. The color that you wind up settling on is largely up to you. There are some realistic and unrealistic views of things. So for example, having it at 0, this is unrealistic here. This is just, it's far too red. The star colors are far too extreme. But setting it too high would be too extreme too, because then the star colors would not show up at all. So you're just trying to strike a balance that fits your eye, really. And again, you can play with the screen stretch as well to see what that every time you click a new setting here, you'll have to play with it again. But you can play with the stretch, with the color balance, with the luminance weight, really to try to get a view that fits your eye, that you like. And so I might stop right there. I'm seeing that there are some stars that are kind of a yellowish color. Those are the fainter, presumably more distant stars. The nearby brighter ones are a whitish color. The nebulosity has a nice pinkish tone to it, which is kind of what I'm expecting from this sort of nebula. And so I'm going to stop right there. Now, there are a couple things left to do. I might still want to try to bring out the color a little bit more, but without messing with these things in kind of a richer sense. But also, I might worry about the blurring that's happening in the center, and especially with galaxies, you can get a big problem where the brightness change happens so dramatically that if you wanted to resolve the center, you would lose all of your detail and the outskirts. And if you wanted to resolve the outskirts, then the center becomes a blurred mess. So we're going to adjust those parameters next. So for now, I'll click OK. I've made a mental note, or even a note on paper, of what my color values were. And so at this point now, I'm going to move on to this next step of refining my color image. So to refine the color, the richness of the color, we can go to the Color menu and go down to Adjust Saturation. And this is where you bring out rich colors. So if you had set the clear or the luminance weight value a little bit too high, you could adjust this. And this is really just something to play with. What I like to do is experiment by jacking it up really high first and seeing what happens. And whoa, that's almost cartoony how bright, how rich those colors are. Very unrealistic. If I set it to, say, 200, then even that to me is a little bit too pink. Especially, I mean, if I'm looking back at my pictures here, I might be seeing, oh, there's lots of pink here. That's what's gone on. These people have adjusted. You can see just the difference in between this color and this color. There's some saturation adjustment choices that are being made there. And again, it's really up to you, since it's your image. So I can play with it a little bit more here. I might kind of like that color. If you really only wanted to apply saturation to certain value pixel ranges, so if there was a particularly bright star that you were trying to accentuate, or a star-forming region or something, then you can actually expand this. For normal images, or for just learning the process, then you probably don't want to do this. But this is something to experiment with down the road if you're interested. I'm going to leave this at 150% because I kind of like the way that looks there. I think if I go 2 more, then it's going to become a little bit too unrealistic to me. So I'll leave it right there. Now to try to work on the central region there. So that is a little bit too blurry for my liking. So I'm going to go up to the Filter menu. And there are a number of different filter tools here that you could play with to try to make things work. The first place that I usually go to is the Digital Development tool. So this gives me a few different tools that I can, or filters that I can try. The first thing I usually try is just none, and seeing what that does here. So if I click Full Screen Preview, you can tell right away what's happened. I've lost my color, my richness. That's okay. I can always go back and turn that up again. But it's made some adjustments to how these pixel values are being distributed. And you can see it in the screen stretch, just how much that's changed here. So what it's done is it has shown a lot of this diffuse structure in the gas that I didn't see before. And if I go back to my screen stretch, I can actually adjust that so that I can bring the background back to black. Okay, so if I wanted to still show the background in space to be relatively black, then I can adjust that red arrow until I get it where I want it. And so you're kind of going for a balance between black color and the loss of detail. So I'll probably put it somewhere around there. Okay, so I kind of like how that looks. There are other ways you can also experiment with the other filters here just to see what the difference is. So these low pass, different kinds of filters do different things. That one seems to have really done a lot of work on the central region where I can't even see that star anymore. Just for comparison, we can turn that off again so you can see that that central brightness there is actually pretty well gone. Got to click on the image again to use the screen stretch tool here. Yeah, so I don't know that I care for that. That's almost too much. Too much filtering. So it's just kind of, until you understand a little bit more of what's going on in the background with these filters, it's kind of just playing almost. But I kind of like how this, whoops, I gotta click on the actual image here. Kind of like the way that that looks right there. Now before I do anything, I need to talk about the next step. So when we're saving this image out into a JPEG format, for example, the pixel ranges matter. So the JPEG standard can only represent pixel values from 0 to 255. So looking along the bottom as I move my cursor around, the letter I there says at this point 10,361, which is much bigger than 255. And of course, when you put it over a star, then it gets even higher. So this range, the dynamical range between very low and very high, is way too big for the JPEG format to actually render. And so what you would get if you were to save this as a JPEG now is something that's actually white, because every pixel, even the black, which is at 9,571, is bigger than 255. In other words, it's bigger than the brightest pixel that JPEG can show. So it would look white. So everything looks white if you were to save this right now. So in order to fix that, we need to convert this to an 8-bit format. You remember early on we saved some things out as 16-bit, which is allowing us to render this much broader or higher range of pixel values. So we need to switch this to an 8-bit format. So I'm going to, before I accept what I've done with the digital development tool, I'll show you what to do if this didn't work. In other words, if the digital development tool did not produce something that you liked. So I will click cancel out of this. I can always come back and do it again. But if that digital development tool just didn't do a decent job of making the image, the difference between the brightest and the faintest something that fits your eye, then we can go up to the process and stretch. So what we're going to do now is process the screen stretch on our image. And there are a few different ways to do this, but we can set it to 8-bit output. And we're going to use the screen stretch. That's another easy mistake to overlook there. We want to actually take the input as what we see on the screen and not something else. So 8-bit screen stretch, logarithmic, and then use the full screen preview. Yuck! Usually the way it works is that one of these options makes the image look awful, and the other one makes it look decent. And then, so of course, you'd take the one that makes it look decent. So in this case, a gamma function stretch is, it didn't actually have any real noticeable effect. And that's okay, because I was going to plan on using the digital development tool anyway to make it a little bit nicer. But this didn't really have a whole lot of effect. You can adjust the gamma values a bit more. For galaxies in particular, this screen stretch adjustment has a lot of effect. It turns out for nebulae, it turns out for nebulae that the digital development tool works pretty well. In fact, the digital development tool usually works pretty well overall. So if you found that one of these did a good job on your image, you would click OK. But then you would also need to come back and do it again, but switch it back to linear. So that's kind of an important step there, is switching it to gamma first, clicking OK, because that's what changes it from 16-bit to 8-bit, and then coming back to the process stretch menu to switch it back to linear. so that things look right. So you got to do both of those things if you choose log or gamma in this case. So right now, since I wanted to actually use the digital development tool, I'm going to go back to it and take a look. I'm going to adjust the screen stretch to bring back my black background. Something like that. Play with my max value a little bit just to see if I can eke out a little bit more detail. No, when I do that, the center region gets a little washed out again. So I might kind of balance it out right there. Maybe I'll bring the black up a bit more. Yeah, something like that. Okay, so maybe I don't like that central region quite as washed out. And this just takes some experimenting. Yeah, that's actually not too bad right there. Okay, so I'm going to click OK and accept what I've done. And now go to Process, Stretch. And since I've already adjusted the stretch, I'll take the input as the screen stretch again. Linear only, 8-bit, making sure that nothing changes, and clicking OK. And now when I mouse around, look at that I value along the bottom there. 39, 2. You know, I expect it to be low around the black background. Expect it to be fairly high toward the center, 245. With that bright star there, it's up to 255. So the brightest object has been rendered based on the screen stretch that I applied. In other words, where I had set those red and green arrows previously, that's what used it to define where 0 and 255 are. So, or 0 and black and white. So it was using that range there. Okay, so now I can finally apply my final crop. Now I'm noticing all these blue speckles here. What I can try to do is there is an option here to actually fix those things by removing the bad pixels. So you could go through very meticulously with the Remove Bad Pixel tool and fix that. Because this is kind of an introduction to this whole process, I usually just take something like MS Paint and go back through and color those blue spots over with black. That's just the fastest, easiest way to go if time is a concern. If you have a lot of time, then you can be more meticulous about it. And there are a lot of places that you could be meticulous, but MS Paint or something similar to color over those blue pixels is often the fastest way to go. So I'm going to now do a crop, and I'll do this by using my cursor itself to drag a box, and you're just kind of cropping in a way that fits your eye again. So I might do something like that, and if it doesn't quite fit your eye, then you can always click out and try it again. There, notice that that background light is actually a star that's just off the frame. I'm not really interested in having that star there, so I will crop it something like this. So you can either drag it freehand, or you can actually go up to Edit, Crop, and this would allow you to specify the dimensions a bit more if you really wanted to have something that was specifically sized. So if I didn't do that, I can just use my cursor, draw a box around this, and then go up to Edit and Crop, and it's figured out what I've done. I can click OK, and crops it down. Then I do my final save. I'm going to save this as a JPEG. Set quality to 100%. Name this something like Final NGC 1579. Save. And then the last thing before you close it all down is to actually go find the image. And there, we can see it in its colorized version. So that tells us that it worked. So that's a little bit a quick run through of MaxIm and how to take those monochromatic filtered images and to make something colored. There are a lot more tools. MaxIm's help does a pretty decent job of explaining some of these other tools. But a lot of it is just experimentation. You're playing with the data. If you wanted to save things at particular steps, then you can feel free to do so. That way you don't have to go back and redo things. Obviously, taking good notes is another key factor. Writing down some of those color balance values, for example. You remember I forgot to adjust my saturation here, so I can kind of illustrate that you can always go back to continue the process. Now it thinks I'm at, it remembers the 150% that I set in here, so if I were to set it back to 100, it wouldn't change anything. But if I use the 150 that's in there again, then it can enhance the color more. Now you'll notice the background turned blue. So going back and changing those saturation values can be helpful if you wanted to undo something or fix it after using some of those dynamic range processing steps. So that's kind of what you're up to. Good luck, have fun, and you can always Google for help if you need it.